Welcome to Finance Concepts by your Finance-ista, Cynthia Bush. In this video, we are going to talk about a topic related to time value of money called annuities. And we'll start with ordinary annuities. So ordinary annuities are simply a series of equal payments received or paid over an even specified time period. These payments or receipts occur at the end of each time period. And if you can invest these regularly, you can earn compound interest. Let's take a look at some examples. For those of you who are making car payments, if you are paying at the end of each month until the loan is completely paid off, you are paying an ordinary annuity. It's the same amount every single month for the life of the car loan. And for the company that you are paying the money to, they are receiving an ordinary annuity. They are receiving the same amount from you at the end of every month over the life of the loan. Another example is a cell phone bill. If you pay your cell phone bill at the end of every month, and it's the same amount at every month, then that's an ordinary annuity. And for the cell phone companies, they are receiving ordinary annuities if you are paying the same amount at the end of the month for the time period that you own the phone. So let's take a look at an example. For problem A, you are saving to pay for housing when you go to graduate school. You will deposit $500 at the end of each year for the next 5 years to earn 6% annual interest. How much will you have at the end of 5 years? There are a couple ways to solve this. Let's look at the first option, which is, I call it the manual way with a timeline. So here we have a timeline starting from today, which is time 0, all the way out to 10 years. Remember, you're going to be depositing $500 into the account at the end of every year for the next 5 years. The first $500 is deposited at the end of this year. So if today is January 1st, you will make your first deposit on December 31st of this year. Notice that that first deposit does not earn any interest. Why? Because initially there's no money in the account. It's January 1st. You don't deposit the money until the end of the year, December 31st. So during that period of time, over those 12 months, there's no money in the account to earn interest. However, once the money is in the account, going forward, each year thereafter until the end of the 5th year, you are going to earn money in the account. And it's going to be 6% interest compounded annually. So notice above the timeline, I have the yellow arrows, which show the number of periods that the first $500 is going to be earning interest. Yes, you're going to have the money in the account for 5 years before you withdraw it, but your first $500 will earn interest for 4 periods. So that's why for that first 500, n equals 4. At the end of the next year, on December 31st, you deposit the second $500. So that second $500 will earn interest for the next 3 periods that it's in the account to the end of the 5th year. So that's why I have n equals 3. Notice that second $500 does not earn any interest between time 0 to 1 or from the first to the second year because that money was not in the account. And then the 3rd year, on December 31st, you deposit another $500 and that money earns interest for the next 2 periods until the end of the 5th year. On the 4th year, you deposit $500. That money earns interest for the next period until the end of the 5th year. And then notice the end of the 5th year, you make your last $500 deposit, and that money does not earn interest. Why? Because you're depositing it on the at the end of the year on December 31st. And then because this is the end of the 5th year, you're then going to take all the money out of the account, so that money has no opportunity to earn interest. So one way we could solve this problem is to calculate the future value of each one of those $500 payments and add them all together. And if you're unfamiliar with how to calculate future value, please refer to my video on time value of money. But once you have calculated the future values of each one of those $500 payments, you add them up, you get $2,818.55. And all the payments were earning 6% interest annually. So the second option that you can do in order to answer this question about how much will you have at the end of 5 years is to use an equation. So the equation to find the future value of annuity is here on the screen. For some people, this can look a little daunting, but please note this is not calculus. This is just algebra. And the way to solve this is to simply fill in the known variables. So I like to start with what's inside the parentheses first. So you take 1 plus the interest rate, raise it to the time period, which is 5, subtract 1, and then divide by the interest rate, which is 6%, and then multiply that by the periodic payment of 500. So when you work through that math, you will end up determining that at the end of 5 years, depositing $500 a year for the next 5 years at 6% interest will have you earn, or will have you have $2,818.55 in the account. We call that the future value of an annuity. It's how much you will have in the future for a series of regular payments made at the end of each period. Okay, the third way that you could answer this question about how much will you have at the end of 5 years is to use a financial calculator. Notice that in this particular question, present value is irrelevant. So depending on the type of financial calculator you have, you would either type in 0 or leave it blank. For your interest, you'll put 6 because this account earns 6% annual interest. For the time period, you are depositing the money every year for the next 5 years. So in the calculator, you enter one number, and that is n equals 5. And then for the payment, that's the $500. And then again, you still want to know what will be the future value of all of that. You solve for FV, which is future value, and you get $2,818.55, the same as doing it with the equation or with the timeline. Okay, here's another problem. And boy, I've swanked up the apartment here. I don't know that many graduate students will be able to afford that. But in any case, it says you need $2,818.55 in 5 years to pay for housing when you go to graduate school. Now the question is, how much should you deposit at the end of each year for the next 5 years if you can earn 6% annual interest? So this is still an ordinary annuity, but notice now you know what the future value is, and you're going to work backwards to find how much is the payment. So you fill in the variables, and when you solve, you find that the payment that should be made every year for the next 5 years at 6% annual interest is $500. So that makes sense based on our previous example. We can also solve this exact same question using the financial calculator. And I like to remind everyone, please recognize what you're solving for. You are looking for what is the payment that you should deposit at the end of each year for the next 5 years, knowing that you want to have $2,818.55 in the account at the end of the 5th year. So in your financial calculator, present value is irrelevant, so you would put 0 or leave it blank, depending on your calculator. We know the future value in this particular problem, $2,818.55. Your interest rate is 6. Your time period is 5 for 5 years. And you solve for your payment. And in the calculator, it will tell you that the payment should be $500 that is deposited at the end of each year for the next 5 years. Okay, so now we've been talking about ordinary annuities. Now we're going to switch and talk about annuity dues. Annuity dues are very similar to ordinary annuities, except the payments occur at the beginning of the period. So if you were to look at the equation of a future value of an annuity due, it is pretty much the same equation as an ordinary annuity, but it accounts for the extra period of interest. So in my original example, when I was depositing $500 a year for 5 years, that first payment didn't make any interest because I was depositing it at the end of the first period. An annuity due would be if I was taking that $500 and instead of depositing it on December 31st, I deposited it at the beginning of the period on January 1st. So then that first payment would earn interest. Let's take a look at an example. You are saving to pay for housing when you go to graduate school. You will deposit $500 at the beginning of each year for the next 5 years to earn 6% interest. How much will you have in 5 years? Since the problem specifies that the deposits will be made at the beginning of each period, it's an annuity due. So again, you have some options on how you answer this question. Let's look at the equation first. And I try to tell everyone, don't freak out on me here. We're still doing algebra. Just start with what's inside the brackets and parentheses, work your way out, and fill in the numbers that you know. Notice for the equation of future value of an annuity due, when you're solving for that information, you put 1 plus the interest rate raised to the time period minus 1 divided by the interest rate times 1 plus the interest rate times the actual payment. And when you work through the math, notice that if you deposit $500 a year for the next 5 years at 6% interest, assuming those deposits are made at the beginning of each year, so on January 1st instead of December 31st, you will have $2,987.66. That is more than what you would have if you had done it as an ordinary annuity and deposited the money at the end of the year. Why? Because that first payment actually now can earn interest since it is made at the beginning. Okay, so let's keep going. And now let's look at a different option. Same question, but the way we're going to solve this one is instead of using the equation, we'll use a financial calculator. And with the financial calculator, again, present value is irrelevant. Your interest rate is 6%. Your N is 5. Your payment is how much you'll be depositing at the beginning of each year, and it's 500. And before you can solve, you need to make sure that your financial calculator is in begin mode. That tells the calculator that this is an annuity due instead of an ordinary annuity, so the calculator knows to assume that the very first deposit is earning interest because it is made at the beginning of the period. So when you solve, notice you get $2,987.66. Okay, so the first example I showed you, it was an ordinary annuity where you're depositing $500 at the end of each year for the next 5 years at 6%. And we determined you would get $2,818.55. Notice for my second example where I changed it to annuity due, which means that those $500 payments are made at the beginning of each year for the next 5 years at 6% annual interest, you end up with $2,987.66 at the end of the 5 years. So if you looked at the difference between the two, notice that you make more money with an annuity due than you do with an ordinary annuity because of the extra period that interest is being earned. And specifically in this example, you make $169.11 more over that 5-year period. Very important to remember, this difference is because the deposits are made at the beginning of the time period instead of at the end of each time period. Okay, that's all for now. Thank you so much for spending time with me today. Until next time, this is your Finance-ista, Cynthia Bush, signing off.